primarily in networks that sort of operate in wireless and mobile environments. And I'm kind of interested in system level aspects, not just how do we move bits or data from point A to point B effectively, even though that's very important, but how do we build systems that provide some kind of a function, right? So sort of an embedded system that includes networks. Kind of the current buzzword in that area is Internet of Things. And so if we think about Internet of Things, it includes networking, because the things need to be connected, need to be able to move data in one direction or both directions. But it also includes the sort of the embedded design of the things themselves. How do we do the processing in the network operations in a way that's cost effective and doesn't consume a lot of power, can be run off a small battery or a solar panel or something like that. It involves then taking that sort of information that moves around and getting it into the cloud and managing and processing that data, using it as part of, to feed machine learning maybe, or to apply machine learning algorithms to understand what's going on in some area. So it's a very interesting, I think, system level problem that has a lot of potential applications, and actually applications already in place today. And in agriculture and environmental monitoring and industrial systems, as well as sort of home automation and things like that. I came to Virginia Tech really with some background in networking and distributed systems. We still have a very strong wireless research group, so as I was just collaborating with other researchers, it sort of became natural to start looking at wireless and doing things in a wireless environment. IEEE 802.11 sort of came around during my early parts of my faculty career, and sort of understanding the performance of that system, starting to understand some of the applications of that system was interesting. Then I've always tended to kind of look at things more at a system level and trying to understand system level performance. How do we design and optimize things at a system level? I think a lot of jobs, a lot of management jobs really require a lot of systems engineering, if you will, because we have, large complex systems with constraints, and we have multiple criteria that we're trying to optimize. And so absolutely having sort of a systems perspective, knowing something about systems engineering is very important, I think, to managing large organizations. I think the future of Internet of Things really does depend on sort of the creativity of applications and where people are using it. And so you have to have sort of an enabling technology, which I think is more where I work, coupled with applications, right? And if we could do this, we could save energy. If we could do this, we could use less fertilizer. Then sort of understanding what the constraints are in terms of how much data, how do you communicate that cost effectively. Agriculture, for example, you're not going to have a huge capital investment. You need things that are relatively inexpensive, that can be introduced incrementally and introduced in a way that doesn't require a lot of overhead to sort of, for the technology, and having technologies that kind of support multiple applications.